So today I'm going to continue from where I left off. So basically going through formatting data, some ideas on how you can debug your code, and then I will start with the NumPy part as well. So, but just finish off the basic Python stuff. So one of the more important tasks that you will do at some point is formatting your data in some ways. We start by just how you print on screen. You probably noticed if you print, for example, floating point, you will get really high resolution, and sometimes you just want to have some number of decimals, for example, or you want it to be looking a certain way, making it in a table, for example. As I said before, there is a lot of methods on the string object, and one of them is the format method, and that can take parameters which you can insert into your string in certain ways. So in this case here, I have a set of 4 variables, and I want to print them out in a certain way. And the format command takes those parameters and inserts them in placeholder commands inside the string. So in this case, the curly brackets in the string here will be replaced by the first parameter, the second curly bracket by the second parameter, and so on. So running this will, running this will produce the following output. You see here that this part here is what I'm adding to this output print. So I want the variables to be separated with a comma. And so on. So this is kind of the basic way of using the dot format method. You can also refer to the variables in your placeholders by using the index. So in this case here, I want my 4th variable to be first, second, 1, and 0. So running this again produces the following output. So you can change the order. But the important part is that you can control also how the variable should be output. So how much character it should take up, the field, how many decimal places, and so on. And that is done by specifying additional parameters in the placeholder. So in this case here, the first character here is just to indicate, otherwise you don't see the white space. So, but the placeholder is this part here. This here is a placeholder, and it says that the colon says that the value behind the colon is the field width. And then I put a string here, and if I run this, you can see here that I have the total length of the new string produced by the format statement is actually 15 characters, and left on the left side. So it adds stuff to your string. So you can get, for example, if you want to make tables, you can use this to make sure that the first column is 15 characters, the next is 20, and so on. Otherwise, you get really ugly output. You can also say that I don't want left justify, I want right justify text. Then I can put a small operator here, larger than, and that basically points that I want the text shifted to the right. So running this, you can see that Python goes to the right side. I can center the text by using this, I don't know what it's called, circumflex operator, and then it centers the text. You can also actually tell the format command to use another character instead of a space. So in this case here, before the centering here, I say I want to have underscores instead of spaces. Yes. And then you can see it fills out the spacing on the right and left side with underscores. Now I'm going to quickly go through the options you have for different data types. So for integers, you don't have that much except for the field width and left and right justification. So it's not really, you can't do so much with an integer. And here are some examples of how you can move the characters. You can also, one option to use is that you can, instead of spaces, you can fill with zeros. So if you want something to be 0, 0 something, you can see here that you can add the spaces with zeros instead. And you put just the character you want to fill with is before the justification operator. Floating point values, there are more options. You can use the F placeholder, and that will produce a fixed field with a certain number of decimal places. So in this case here, you still have 10 here is the field width. .2 is the number of decimal places, and F is that you want to have it fixed. So you don't want scientific notation, you want a fixed decimal output. So here I have 2, 4, and 6 decimal places. You can force scientific notation by using the E operator. And then it will always display in scientific notation. Let's see, this one should be there. The G operator is kind of a mix. It kind of chooses the format depending on how much space you have. So if it's suitable to do fixed, it does fixed form. If it doesn't fit, it will go over through and do scientific notation if possible. Now we're coming into more cool stuff here. So you can also name your placeholders. So in this case, for example, I have an X and Y coordinate, and I can name them and use the names in the placeholder specification. So in this case here, you can curly bracket X, curly bracket Y. That refers to the variables that you send into the format statement. And it's also possible to, for example, send over a dictionary with key value pairs, and the keys can be used as placeholder names. So in this case here, you can see I have value 2, value 3, and then I can use these names inside my formatting statement. And this is the star here is that you want to pass the dictionary over as by reference. So it's a bit odd, but that's what you have to do. And if you run this here, you can see here that it inserts the values from the dictionary directly here, depending on the name. And the same thing with this one here. Another cool thing is that there is a function in Python called globals that returns you a dictionary of all your variables in your current context. And you can actually use this to make formatting even easier. So in this case, I have declare my variables here. 1, 2, I can just show you what it's inside is. So you can see here that you get a dictionary of everything that is in your current workspace. So everything, one thing you learn from this code, everything in Python is a dictionary. The classes, the objects, the functions, they're all basically dictionaries. You can access them, so you can modify your own environment by using this. So in this case, I have 3 variables. And now I just passed the globals dictionary to the format statement, and now it fills the variables directly inside my placeholder. And this is the technique that is used when we go to the next section here, which is really cool, is the F strings. And F strings they're called formatting strings. They have this feature built into them. So you don't have to use the .format statement anymore. You can just prefix the string with an F and then use your variables directly here. So in this case, this is the prefix F format string, and then you just put curly brackets in your the following string, and it will take the values from the variables in your context. You can use the same formatting specifiers that I showed before in the format statement in the formatting strings as well. I think this is really cool, and it makes your life much, much easier. You don't have to do any complicated formatting with .format. You can just put your variables directly into the strings. And also you can control the number of decimals directly by using colon, and you can use the fill character as well. So it's a really nice feature. So here you can see I put name, age, So you can think of the format string as templates. You can one thing you can do is you can use double quoted strings to create really long, for example, configuration file template, and then you have placeholders inside that will be replaced when you print them. And you can see here that you can actually have expressions in your placeholders as well. And you can call functions on things inside. So you're basically a meta interpreter inside a string. Really cool. Yeah, as I said before, you can have the same formatting commands as you have for the dot format. And this is some other usage of it. With using the expression features that you have built in. Yes. The next is, so now we have printed to your terminal or your standard output, but mostly you will read and write files. You parse a file, you want to do something, you want to write results from your computations, so you need to be able to read and write files. And in Python, it's a two-step process for doing either of these. First, you have to create a file object. And when you do that, you associate a file name on your disk with an object in Python. And you do that with the open statement. So we start by, we want to write a file. So the first thing we have to do is create a file object. So we do that using an open statement. So text file equals to open. First parameter is the file name of the file you want to open. And in this case, it's a new file, so we want to create this. Second parameter is what you want to do with the file. So in this case, you supply a string here, and W is for write, and I will go into read later on. And there are some other options you can do also for writing binary files, but we'll start with text files. Then there is, on the text file object, we have a lot of methods, and the most common one is the .write. That will write a string to your file. It's not similar to the print statement. The print statement will add a line break. .write will not add line break. So line breaking you have to do yourself when you write to files. So you can see here. It also returns how many characters it wrote if you want that. You don't have to do that if you don't want to. And we can look at the file here. It should have a myfile.txt here. Oh, I didn't close the file. Let's see here. We closed that myself. So you need to, when you write the files, you need to tell the operating system when you are done working with the file. So in this case, we still have a file object open. That is, the file has not been completed. And usually, most operating systems, they don't write directly down to disk. They wait for at some point that you close the file, or there is too much in the buffer, and then it writes down. So it's not necessarily that you get things in the file directly. So let's see, we continue here. And what you have to do at the end when you are done, you tell the file, I'm done with this file now. So I call close. And now we can look at the contents of the file here. No, I did it but the interesting thing here is this part here. So when I write file content here, that will be on the same line. There is no character return, and then the next line here is written directly after this here until you have a \n here, which is a character return, and then it goes to the next line, and then write will continue on the next line. So you have to add the \n or the character return yourself. Reading from file is basically the same procedure. You need to associate a file object with a file name. The second parameter will now be R for read. And instead of writing, you will use the read methods. And in Python, as I said before, there are so many ways of doing the same thing. So of course, you can read files in many different ways. One way I will show you first here, so I will first open the file. There is a method called read. That reads the entire file into a string. Can be convenient for smaller things, but just think if you have a file that is a couple of gigabytes, you will have a gigabyte string object, and it's not what you want. But you can do it. So I do read, and then I close, and then I can print the contents of the file like that. Usually when you read text files, you read them line by line. And that you can do using the read line function. That will read until a character return that string. So you can do you can create a loop for this. So in this case we have first we read a single line using text file read line. Then we do a while loop. So if the returned value from the read line is not empty, we continue reading. So when the read line is empty, you have reached the end of the file. So in this case, you can see that we read one line when we print it out. I added a small character here to see what the print statement does. But you notice here that there is an extra line here. And that is due to the fact that when we do the read, it will read the character return as well. So the string will contain a character return. If you print, it will add a character return. So you get double the line spacing here in this case. So that's why we have this extra here. We can fix that by using write strip. So every time we read in anything, we stripped the right side of the string. That means actually removing the character return. Running this, you can see that we get every line on a single row. But of course you can do this in many ways. So you can actually loop using the for statement. You can loop over the lines of a file automatically. So you open the file just like before. You do a for line in text file. That will iterate over the file. It will read one single line every time, and you can process that line. I think this is it's a really cool feature. You don't have to do a while statement. You can just loop over the file and process it. There is a convenience function for that, so you can do that in a single line. So if, for example, if you want to read your text file into a list, you can use read lines, and that will read the lines and put every line in an item in a list. So then you can process the list afterwards if you want. And that is if you want to read a text file and work on it randomly, you want to access different parts at the same time. You don't have to go sequentially. You can read the entire file, and then you can work on it using a random access pattern. So that you can see here, I have a list here. Of course, it will add your character returns as well in the read line. So you get those as well for free. So you need to think about that when you're processing the lines in the file later on. So then you basically do a for line in lines like this, and then you do like processing. So this is usually what you do afterwards. Right strip. One thing that you have to think little bit about, not too much, but when you open things, you need to close a file. And if you don't close a file, you can get problems when the script quits, that you're not sure if everything has been written. So to be able to make sure that you call the close statement, you can use something called a with statement. And what with does is when you open a file, like for example here I have with open my text file as text file, I still get my text object, but the with statement guarantees that the close is called. It will actually do it automatically for you. So basically you open a file, and you, in the indented part here, you do your file operations, and when you exit this code block, text file will be automatically closed. There are some other for example, if you work with networking in Python, you also use with, and then you can guarantee that you close the socket, for example. So the with statement is a thing that makes sure that you close something that takes resources. So in this case, you get the same as before. Error handling in Python. You probably, if you run Python, you get this kind of really long error messages when something is wrong. That is the kind of error message you get when you run Python. But usually you want to try to avoid giving the users that output. And the first thing you can do is make sure that you check the preconditions of everything you want to do. For example, here I want to open a file. First, make sure that the file exists. So we can do if OS path exists, which is the function in the OS module. And not until we have that, we know that the file exists, we open the file. Otherwise, we print out we couldn't find the file. So in this case here, it worked. But if I put in here, for example, file name 2 and run this, you see that the file couldn't be found. But what we can do in Python is also if you look at we can see here, we can open the file here just to trigger this. We run this, you will get something like this. And here you can see some of the parts we're going to talk about in the next section here. So you can see you get this kind of strange text here in the beginning, file not found error, and then you get a clear text description. When you have an error in Python, Python will throw something called an exception. And the exception comes as an object, of course. And the file not found error is an exception object that is thrown by Python. And if you don't do anything, your program will stop, as we see here. We can handle that. We can actually, actually this will also produce the same thing here. But we can use something to catch these objects. And in Python you use a special statement called try. So it's what it is, you try execute this code. And if something happens, I want to go to certain code blocks. So in this case, it will try to execute this code block here. If anything happens, it will go to this code block here. So in this case here, I will not get this ugly error message. I will just get the file couldn't be opened. Execution is still in my Python code. It will not stop execution. It will continue afterwards. This approach is, however, a bit dangerous because if you have a bare except like this, it will catch any exception object. So basically, you don't know. It could have been an error that says that I couldn't access the file, but we don't know because we catch everything. And we just print out the file couldn't be opened. So we need to be able to have more fine-grained control of this. So we want to be able to handle specific exceptions that we want to handle. So for example, if you go back to the file not found exception, we can actually catch that one only, and then we specify here try, and we will get the exception file not found. We will actually print that out. Otherwise, if we have another exception object, it will crash. So you have to be careful to hide the exception, because it could be a critical thing, that is your computer doesn't work anymore or something like that, and you don't want to continue running after that. You can also catch multiple exceptions. You just continue listing what you want to catch. So in this case, permission error, for example, that is, if you don't have permissions to read a file, you will get a permission exception. Also, if it couldn't convert to float, you can have a value error, and we will see that later on when you convert in the user interface part. When we all user interface control in the user interface is text strings. And when you convert a text string to a floating point, Python can fail, and then it throws a value error, and then you can catch that. So in this here, you get the value error here because we try to convert a float from a string, and that doesn't work, and then it catches this converted float. If we only had the accept statement before, we couldn't open the file. So you hit that conversion error because you catch all exceptions. You can get more information from exceptions as well. So all exceptions comes with a clear text error message. So you can do file not found error as E. So then we basically say we catch the exception and store it in a variable called E. And then there are methods and properties on that error we can parse. For example, if you have a file not found error, it will set a property called file name. So we can actually say which file name it couldn't open. You can also get a string error message using the str error property. So now I didn't have this on my file. Couldn't be open. So now we can see here that you can from the exception you can actually get the actual file name that couldn't be opened. I think you can also get so here this is the message that is generating from the file not found error object. So it said no such file or directory. So that is the actual error message. There are other ways you can do things. For example, sometimes if you have an exception and you know that, okay, something happened here, but before I close the program, I need to clean up my execution somehow. There are certain things I need to do. I need to remove some scratch files and stuff like that. There is another try you can use, and it's called finally. Finally will always be called, even if there are exceptions. So you are guaranteed to have this part here executed at all times. So you can see here I had input file not found, so that is an exception. And then the finally part here is always executed. So that is a good way of ensuring that when I have an error in my code, I clean up properly certain ways. Then I have some points here when you start writing your code. There is a code style guidelines for Python called, and they have a document naming that is called PEP, and it's called PEP8. How you name variables, and in Python, the rule is that you have your variables are lowercase, and if you have multiple parts of you have underscores between them. Also try to use descriptive names. That is also a rule. So instead of using n, you use student count. If you have constants in your program, usually you put them in uppercase. When you import stuff in your modules, one good idea is to first put your standard library imports in the beginning, third party as the next step, and your own imports as the last part. And also try to separate them in different parts so you can differentiate them. Debugging techniques. Yeah, of course you can have you can do printf statements. That is the kind of the classical way of debugging your code. You print often. That is also sometimes there's another way of doing this using something called logging. We will also go. No, we don't do that. Yeah, we go that next time. So, but you print out what you're doing during your code execution. I will also show you here afterwards that you can actually run debug in Visual Studio Code. Another thing is that validate input. So if you're getting input from your user, make sure that the values are what you expect to get. Did the user enter a string? Okay, then we have to see, can we convert it? So in this case, we have Input is a standard method in Python which takes asks a question to the user and it returns a string. So the first thing we have to do is we have to convert it to a floating point. And in Python that is really easy. Every data type has a conversion function. So float, parenthesis, string will convert to float. Any data type into parameter. Same thing with int. However, it will throw an exception if something is wrong. So if everything is correct, we have to check, okay, it needs to be a positive number. We just check an if statement here. If we got an exception, it will continue here and print out that you didn't enter a valid number. Now I'm not sure if I can't execute this here. Another part is when you are working with files, use exception handling. Make sure that you cover the cases when you read a file. So here they put everything in a single function, read data file. And then you have try except, you have the with statement here, guaranteeing that we were closed. You handle different errors, and you return none if it couldn't read anything. And then if you have a read data, when you read here, you have to check, did I get any data? So here you put all the ugly file permission stuff in a simple to use file, and then you can just check, could we read or we didn't get the data here in a simple if statement here. Let's see here. Yeah, then we have, you shouldn't, if you have, let's see here. Yeah, this is a empty string, and it's mute. As I said, we can change that, and here you create a new list and return that to the string. So this is yeah, you can use none in the parameters here. Variable ref, I covered that already, so I don't go through that here. Some of the more modern features is something called list comprehensions, and they have made a notation to create new lists without looping directly. And for example, here I have an empty list here, squares, and then I loop here and append values to that list like this. And this is one way of doing it, classical way of doing it. The new way of doing it, you can do it directly in list. You create squares equal to list. You have your loop, what you want to compute here, and then you have your for loop here as the second part of the list. Or that will actually directly call the loop and create a list with that content. And you can do a lot of stuff here. For example, here you can have a conditional here as well. You can do string manipulations, a lot of stuff here. This here is, we will come to that in the next section here with NumPy. You shouldn't use lists as matrices in computing, because this list is not efficient for matrix computing. I will explain that in the next section. List is a flexible data type, but it shouldn't be used for computation. Yeah, that's what I wanted to show today. So So next I will start to look into NumPy.